Good day, learners. Welcome back to our chemistry class. In today's class, we are going to proceed on our calculation on Gay-Lussac's law and Avogadro's law. Majorly, Gay-Lussac's law. Today is going to be the calculation. Just before we venture into this, if you are a new member on this channel, kindly subscribe to my channel and click the notification bell for my subsequent content. So, let's move on. Example 1. Water vapor is produced according to the following equation. Hydrogen reacting with oxygen to give water, that's water vapor as a gas. What volume of oxygen will combine with 10.0 centimeter cube of hydrogen, and how many centimeter cube of water vapor will be produced under the same conditions of temperature and pressure? In this case, we are to calculate two things. The first one is to calculate the volume of oxygen. Now, considering this equation given to us, this is the equation. 2 volume of oxygen combining with 1 volume of hydrogen to give 2 volume of water. This is Gay-Lussac. Now, we're not told to find what volume of oxygen to get the volume of this oxygen. So 2 volume means 2 centimeter cube of hydrogen gives 1 centimeter cube of oxygen. So we are told to find the volume of oxygen that will combine with 10 centimeter cube of hydrogen. So 10 centimeter cube of hydrogen will give how many centimeter cube of oxygen? Let's call it an unknown, x. Cross multiply, 2 multiplied by x, I have 2x, is equals to 10 multiplied by 1, I have 10. We divide both sides by 2, divide by 2. So x is equals to 5 centimeter cube. So this means that volume of oxygen is equal to 5 centimeter cube. Now, the next one is to now find how many centimeter cube of water will be produced. Now, look at this. I want to know the volume of this water that will be produced. You can calculate it from either that of hydrogen. You relate hydrogen to water, or you relate volume of oxygen to water. You still arrive at the same thing. Now, I want to make sure of this hydrogen. 2 centimeter cube of hydrogen is reacting, 2 centimeter of hydrogen is producing 2 centimeter cube of water. Are we there? Then for this hydrogen, we have 10 cm cube of hydrogen. So 10 centimeter cube of hydrogen will now produce how much? Let's call it y. So cross multiply, 2 times y, I have 2y is equals to 10 multiplied by 2, I have 20. So divide both sides by 2. So my y is equal to 2 goes in 20, we have 10 centimeter cube. So which means that 10 centimeter cube of water vapor was produced from 2 centimeter cube of hydrogen. And if you like, you can also make use of this oxygen. That is 1 centimeter cube of oxygen we produced 2 centimeter cube of water. And if you can recall, from what we got 5 cm cube of oxygen. So 5 cm cube of oxygen that we got then is going to produce how many? Let's call it Z. Let's cross multiply. Z times 1, we have Z, is equals to 5 multiplied by 2, I have 10 cm cube. And don't forget, Z is under water vapor. So which means we are going to have the same answer. Either you use that of hydrogen to calculate water, or you use oxygen to calculate water, we arrive at the same answer. Number 2. Ammonia is produced by other process according to the equation, nitrogen combining with hydrogen to give ammonia gas. If 20 cm cube of nitrogen were mixed with 90 cm cube of hydrogen, under suitable conditions. Question A, which gas is in excess and by how much? Question B, what will be the volume of ammonia produced? Question C, what is the total volume of the gas mixture at the end of the reaction? Now, looking at this equation, we have nitrogen combining with hydrogen to give ammonia gas. Before we now move on properly, one thing we have to realize, we have to understand two things. What we call limiting reagents and excess reagents. Now, when we say limiting reagents is that reagent or that gas that is being used up during that chemical reaction. While the excess reagent is that gas that remain after the reaction. Some gases will react, part of them will react, the remaining one is called excess reagent or excess gases, or sometimes we call it residual gases. Now, let us now look at how to determine the limiting reagents and the residual gases. Here, let's using the Gay-Lussac's law. 1 centimeter cube. If I say 1, I'm talking about the number before it. 1 centimeter cube, then reacting with 3 centimeter cube of hydrogen, these 3, to give 2 centimeter cube of ammonia gas. Fine. Now, if 20 centimeter cube of nitrogen were mixed with 90 cm cube of hydrogen, let's assume that hydrogen is used up. I'm just assuming. I can also assume nitrogen is used up. I want to know which one is used up. If I want to assume that hydrogen is used up, I want to make use of this hydrogen now. So 1 cm cube of nitrogen gas reacts with 3 cm cube of hydrogen gas. Now coming to this place, nitrogen is 20 cm cube. So 20 cm cube of nitrogen gas will produce how much of hydrogen? Cross multiply, s times 1, x equals to 20 multiplied by 3, I have 60 centimeter cube of hydrogen. Now, which means that if 20 cm cube of nitrogen is reacting, it must produce 60 cm cube of what? Hydrogen. But what were you given? We were given 90 cm cube, which means that only 60 cm cube of hydrogen is reacting out of what? 90 cm cube. Are we there? So which means that hydrogen is not used up. Hydrogen is not used up. So instead, the remaining part of hydrogen now is 30. The remaining 30 centimeter cube is called excess reagents. Now, let us now assume that nitrogen is used up now. If we assume that nitrogen is used up, nitrogen, 1 cm cube of nitrogen combining with 3 cm cube of hydrogen. Now, how many cm cube of nitrogen will now combine with 90 cm cube of hydrogen? If I want to get the number of nitrogen being used up, cross multiply 3 times y, 3y equals to 1 times 90, 90. Divide both sides by 3. So y is equals to 3 goes to 90, we have what? 30 cm cube of what? Of nitrogen. My dear students, if you can look at this is 30 cm cube of nitrogen. And initially, we started with 20 cm cube of nitrogen. Definitely, all these 20 have been used up. Instead of us to get 30, we were given what? 20. So this nitrogen is called limiting reagents. So the limiting reagent is that reagent that is being used up in that reaction. While the excess reagent is the reagent that remains after the end of the reaction. Now, Question A. Which gas is in excess? Comparing this now, 60 cm cube of hydrogen instead of 90 cm cube of hydrogen. Can you see it now? You can see that hydrogen is in excess. Now, by how much? And by how much is going to be that 90. So in this case, hydrogen is in excess by how much? By taking away that 60 that we got from 90 to give us 30 cm cube. So that is question A. This has answered my question A. So hydrogen is in excess by 30 centimeter cube. Question B. What will be the volume of ammonia produced? This ammonia we want to produce, what is going to be the volume of that ammonia? From here, you can calculate ammonia, volume of ammonia from either your nitrogen or from your hydrogen. Now, what will be the volume of ammonia produced? So from here, we can say, I can get the volume of ammonia either from nitrogen or from hydrogen. Let me use hydrogen. 3 cm cube of hydrogen produces 2 cm cube of ammonia gas. Now, what is the volume of hydrogen that we got? We got 60 cm cube of hydrogen will now produce how many of ammonia? First multiply 3 times x. 3x is equal to 60 times 2, 120. So divide both sides by 3. So x is equal to 3 goes in 12. We have 4. That is 40 cm cube of ammonia gas. So which means that the volume of ammonia gas produced is 40 cm cube. Likewise, if we make use of nitrogen, we are going to arrive at the same answer. Now, if you are a new member on this channel, kindly subscribe to my channel and click the notification bell. And don't forget to share and like this lesson. Question C. What is the total volume of the gas mixture at the end of the reaction? Total volume of the gas mixture. Total volume of the gas mixture will mean the volume, the excess volume. And don't forget the gas that is in excess. It was hydrogen. By how much? 30 cm cube. And also, ammonia gas will also be in excess. Because initially, the volume of ammonia was not given. And we got final volume. So that final volume plus excess hydrogen gives what is called the gas mixture at the end of the reaction, which is the residual gases. Residual gases is going to be equal to hydrogen plus ammonia gas. Our excess hydrogen that we got the other time, we have 30 cm cube plus the volume of ammonia gas we got here, 40 cm cube. When we sum it up, we have 70 centimeter cube. So which means the total volume of the gas mixture at the end of the reaction is 70 centimeter cube. Example 3. What volume of hydrogen will be left over when 300 cm cube of oxygen and 1000 cm cube of hydrogen are exploded in a seed tube? Given this equation of reaction, we want to know the volume of hydrogen that will be left over. From this, 2 volumes of hydrogen combine with 1 volume of oxygen to give 2 volumes of water. From here, 2 centimeter cube of hydrogen gas reacting with 1 centimeter cube of oxygen gas. Now, what volume of hydrogen will be left over? Hydrogen now. How many volume of hydrogen is going to produce that of oxygen, which is what oxygen is 300 cm cube, 300 centimeter cube of oxygen. Because we are asked to find the volume of hydrogen that will be left over. So, cross multiply, S times 1, S equals to 2 multiplied by 300, we have 600 centimeter cube of oxygen. Now, we are asked to find of hydrogen, we are asked to find the volume of hydrogen that will be left over. From this question, we have 1000 cm³ of hydrogen. But when the reaction occurs, we can see that only 600 cm³ had reacted. Definitely, we have to take away 600 from 1000 to get the leftover of hydrogen. Volume of leftover hydrogen will be equals to 1000 cm³ minus 600 cm³. So this is going to give 400 cm³. So the volume of the leftover hydrogen is 400 cm³. If you are a new member on this channel, kindly subscribe to my channel and click the notification bell for my subsequent content. And don't forget to like, share this lesson so that other learners can also benefit. You can also lay your hand on the following assignments. Send it to me for me to check it, maybe they are correct or not. And in that case, I would like to correct you. I remain Latif Ismaila Akambi, your mathematics and chemistry tutor. Thank you.